In this video, we'll be talking about Module 3, Topic B. Topic B covers lessons 7, 8, 9, and 10. And they have us looking at angles and building equations with angles and solving those missing pieces. Basically using algebra to get us ready for the rest of the module dealing with algebra. So the first thing we can look at is all of the different angles and angle relationships that we're going to be dealing with that we need to know in order to do these things. So the first angle you see here is an acute angle. It's the small angles. Those angles usually go between 1 degree up to 89 degrees. The more important angle that mostly everyone knows is the right angle. The right angle is equal to exactly 90 degrees. And you know you have a right angle if you see that symbol down there in the corner. Anything greater than 90, so from 91 degrees all the way to 179 degrees, you'll find an obtuse angle. The other one that's just as important as the right angle is a straight angle. It's formed a straight line, and those are equal to exactly 180 degrees. And then the last one is a reflex angle. Reflex angles are anything above 180, so 181 degrees, all the way to 359 degrees. And then obviously a 360 degree angle would just be a full circle. So the most important ones that we need to worry about are right angles, because we're looking for stuff that might be equal to 90, straight angles because they're equal to exactly 180, and then of course circles, they're equal to 360. So we're looking for the things that are equal to exactly a number rather than a range like you see these other three. And then we have these different types of angle relationships. So these are all just as important as right angles and straight angles and circles. These tell you how to build your equation. So a complementary angle is two angles, only two angles, and when you put those two angles together, add them up. So if I told you that this angle was equal to x and this angle was equal to 10, that would be x plus 10 would be equal to the 90 degrees. Complementary angles. Just like complementary angles, supplementary angles are two angles that when you put them together, they make a straight angle, like you see down here at the bottom. They have that straight line. Those angles, when you add them together, equal to 180. Supplementary angles also have another name. They can also be called linear pairs. Pairs meaning that there's two of them, and linear meaning that they form a straight line. The next angle that we can look at, which is very close to supplementary angles, are angles on a line. Angles on a line are angles that form a line equal to 180, but it can be more than two. And you can also be two. So a supplementary angle can be called three different things: supplementary, linear pairs, or angles on a line. What make angles on a line a little bit different is that it can be more than two. So right here we have 1, 2, 3, 4 different angles that can be all added together and be made equal to 180. The next one would be angles on a point. Angles on a point mean that you have a bunch of angles that go around a point. And if you were to add up all of those different angles, so here we have 2, 3 angles, 4 angles, 5 angles. If we add up all of those angles, you see it makes a circle, so that would be equal to 360 degrees. And then the last one we have here is opposite angles. Opposite angles are formed when lines intersect. Anytime you have two lines that intersect, and you can see that you have opposite angles. Opposite angles face opposite directions. They're also called sometimes vertical angles. And the most important thing about them is that they are equal to each other. So if this angle is equal to 40 degrees, this angle is equal to 40 degrees. Also important is that if you have one set of opposite angles, that means you also have a second set. So this is opposite of this. And they are both also equal to each other. Now let's see how we're going to use this information to find missing angles. So in this particular problem, they want us to find what is the measure of angle BGA. And as you can see inside that angle, we have a letter X for a variable, unknown. So looking at this, the other information that I see is that we have a 30-degree angle here. And if I take that angle BGA and I add it to angle CGB, you can see that those both ends of that arc that I just made stop on angle CGA. And angle CGA is obviously equal to 90 degrees. So in building our algebraic equation, we can take that first angle, angle X, and add it to the angle that is equal to 30 degrees and make that equal to the whole angle CGA, which is equal to 90 degrees. So now it's working out algebra is what we need to concern about now. So in algebra, I'm trying to get the variable by itself. So I need to get rid of this plus 30. Anytime you want to get rid of something, you just do the opposite of it. So the opposite of adding 30 would be to subtract 30. And anything we do to one side of the equal sign to keep it equivalent, we also do to the other side. So here we have 30 minus 30, that equals to 0, leaving us with only X on the left-hand side of the equal sign. And then 90 minus 30 is going to be 60. So that means that angle BGA, and that's how we write angle BGA, is equal to 60 degrees. Third problem from another problem from lesson 7. We have some information up here that says angle DBA is a straight angle. Knowing our angles and angles relationships, that means that angle DBA, this line here, is equal to 180 degrees. So to find this X, we take this angle X and this angle that is equal to 23, add them together. They both touch this straight angle. So we just put it equal to 180. X plus 23 is equal to 180. We're going to do X plus 23, subtract 23 to get rid of that, is equal to 180 minus 23. It's very important to do these algebra steps. Yeah, you might want to do math all over the place and just circle an answer, but these algebra steps are very important for the rest of the module, which is the reason why we need to get in the habit of doing these. So 23 minus 23 is 0, leaving us with X. You can do your math off to the side. Like I'm going to go ahead and work out this 180 minus 23 just off to the side. So we get X is equal to 157. So there's our X. That is also what this angle here is equal to. And then it says to describe the relationship between angles DAC and CAB. Well, we already did that, really. We went ahead and said that those two angles put together equal to 180 degrees. That means that they can be called supplementary angles because it's two of them. They can be called linear pairs because it's two of them. Or they can also be called angles on a line. And if you want to check your answer, you can simply take the number that you found and this other number right here that they already gave to us. We know that they should equal to 180. So if you add those two numbers up, you can see that your answer does in fact equal up to 180. So you know you got the right answer. In problem 5, it shows us why topic A was so important, because here we have 3 different angles. All 3 of these angles, if you notice, putting them together makes angle CAB, and angle CAB is a 90-degree angle. So the relationship with these is that there are no names. There's no name for 3 angles making a 90-degree angle, but this is just angles that added together form a 90-degree. So we can start adding these together. So we got 25 plus x plus 25, and that equals the angle CAB. That is equal to 90. Now from the last topic, we have to look at the left-hand side and simplify that to the fewest amount of terms to make it as easy as possible for us. So nothing can add to the x. There's no other x's, so that stays here. 25 plus 25 gives us 50, and then that's equal to 90. And that's as simplified as we can get the left-hand side. Now we just do our algebra. X plus 50 minus 50 is equal to 90 minus 50. So then x is equal to 40. Therefore, angle EAD is also equal to 40 degrees. And the last one from this lesson 7 tells us the information up at the top. CAB is a straight angle. Obviously, it's a straight line right here. Looking at these relationships, all of those angles are angles on a line. So CAE, EAD, DAF, FAB, add all of those together, it makes a straight line. So let's go ahead and write that equation. So we've got x plus x plus x plus the last one is 3x. That equals to a straight angle 180. And if we combine on all like terms, we have 3 x's. This is 4, 5, and 6. So 6x is equal to 180. Now, just like when we were getting rid of addition and we did the opposite, here we have multiplication. So the opposite of multiplying by 6 is to divide by 6. And if we divide one side by 6, we have to divide the other side by 6. 6x divided by 6 is going to leave us with 1x. And then 180 divided by 6 is going to give us 30. So if we want to find all of these missing angles, any of them that are just x is going to be equal to 30. But then the last one is 3 times x. So that would be 3 times the 30, which would give us 90. And if we want to check all of those numbers, 90, 30, 30, and 30, add all that together, and you get 180. Lesson 8 was a digital lesson that we actually did on paper. We had a packet to do. And it's really just the review, more practice on lesson 7. Lesson 9 is where it starts to get more complicated, and you have to really be able to know those relationships to be able to work these problems out. So in lesson 9, this is problem number 2. They give us some problem that can be worked several different ways. So one way we can work this problem is going through the steps, going through our relationships and looking for things. So I like to go in order with my numbers. The ones that we talked about in the first slide were 90, 180, 360. So looking at this problem, first thing I'm looking for is, do I have any 90-degree angles? And there are no symbols for that, so that's a no. Second one I'm going to look at is, do I have some 180s? Do I have some supplementary angles on a line, those type of things? And I do see a line here. We have one line here. And to form that line, I could go this way and add 35, but then right here I have nothing to add. So you can't use an angle that has no information for you. So I'm going to get rid of that and go this way. So if I add these two pieces together, that would give me 5x plus 7x plus 96 is equal to 180. So that's going that way. But I also see another straight line here. And that straight line is this line. So again, can't go this way because we have nothing here. But I can go this way. And that problem would be 7x plus 96 plus 35 is equal to 180. So to solve these two problems, we have to simplify the left-hand side of the equal signs and then use our algebra to go ahead and come up with what x is equal to. I'm going to pause the video. You could pause the video because it's not going to pause if you keep playing. But work these two problems out. Make sure you can come up with the same x as me. So while I was working out the green equation, I realized that this is actually the first time, if you were missing class, that you've seen a two-step algebra equation. So I figured the red one, I'd go ahead and work it with you so you can see exactly what it would look like. So if we were to go ahead and simplify the right-hand side of this red equation, there's nothing to add to 7x, so we would just bring that down. 96 plus 35 gives us 131, and it would still be equal to 180. This, what you see here, this simplified version, is called a two-step algebra equation because it takes 2 steps to get the solution. So, and it's going to be 2 steps because in 7x we have multiplication, and then in the plus 131 we have addition. We have to get rid of those in 2 steps. So we always get rid of the easiest stuff first. The easiest thing to get rid of here would be that plus 131. So to get rid of plus 31, it's the same thing as the last lesson. We're going to subtract 131 from both sides. So these two 131s equal to 0. We have 7x here. 180 minus 131 gives us 49. So that was the first step. Now the second step is to get rid of that times 7. And just like the problem that we had in the last lesson, to get rid of multiplication, we divide by the same number. So we're going to divide both sides by 7. 7x divided by 7 leaves us with x. 49 divided by 7 is 7. So as you can see, both of these answers, even though we worked them out differently, came up with different equations, because we know our relationships, we have the same exact answer. But there is also still one more way that we can work out this problem and find out what x is equal to. And that's by a different relationship other than 180 angles on a line or supplementary angles. So we know that there's no complementary angles because there's no 90-degree angle. We know that we obviously have 2 different supplementary angles that we could have used. 360 angles on a point actually would not work because, again, we don't have this angle, so I can't add everything up and make it a circle. But what I do see here is that I have 2 lines that intersect or cross, so that means that we have vertical or opposite angles right here. So 5x and 35 are opposite angles, which means that they are equal to each other. So another equation that I could write, because I know that relationship, is just simply 5x is equal to 35. Opposite angles are equal to each other, so I make the equation equal. To get rid of times 5x, we divide by 5, divide this side by 5, and we get x is equal to 7. Knowing these relationships, being able to see these different things, can make the problems a lot easier for you. So then if I want to find what the measures of these different angles are, we could do 5 times x, which we just found out was 7. So this side is equal to 35, obviously, because this side is also equal to 35. And then at the top, we would have to do 7 times 7. And then once we do 7 times 7, we add 96 to that. And we get that this side is 145. And because this side is 145, and we always have 2 sets of opposite angles, I know that this angle is also equal to 145. And if you want to check this to make sure that you have all the right numbers, if you add all four of these numbers up together, they would be equal to 360 degrees. Now, speaking of 360 degrees, this problem here, as you can see, there are going through the list again, there's no 90-degree angles. There's no 180-degree angles because while these lines are straight, they don't go straight through the point like so. There's no straight lines like that. The lines don't create straight angles. There are no opposite angles here. The only thing that is possible is angles on a point. So if we take all three of these angles, add them all up, we will have our answer, our equation. So describing the relevant angle relationship, relevant meaning which one's going to give you a number to put it equal to. This one would be angles at a point. So if we take all of these numbers and go ahead and just put them into an equation, we have 3/4 x plus 9 plus 1/2 x minus 17 plus another 3/4 x plus 9. So with this equation, we can go ahead and start working it. Very first thing that we need to do is get rid of this minus sign here and make that become a negative 17. Then I'm going to go ahead and group all of my like terms together. I'm also going to change that 1/2 x to be a denominator of 4. So we have 3/4 x plus 2/4 x. That's that 1/2 plus 3/4 x. That takes care of all of those. Then we got a 9 plus 9 plus a negative 17. So if we got 3/4, 2/4, another 3/4, that equals to 8/4 x plus 9 is 18 plus a negative 17 is going to give us 1. And that's all. Forgot to put my equal to. That's all equal to 360. And then we go ahead and get rid of that plus 1. All right, actually 8/4 I can make into 2x. So plus 1 minus 1 is equal to 360 minus 1. We divide both sides by 2. And we get that x is equal to 179.5. So there we have our x. If we want to find all of these different angles, we would plug that in for x. So because I have a decimal, I'm going to change this 3/4 to 0.75. Then we multiply that times what x is. Once we multiply that, we go ahead and add 9 to that according to this angle. And that would give us an answer of 143.625. And this equation is the exact same thing. So that angle is the same thing as this one. And then down here for angle ABC, we would do 0.5 times 179.5 and then subtract 17, and that would give us 72.75. So those are our missing angle measures for all three of these angles. And if we add them all together, we would get 360. This last problem we have here from lesson 9. We're looking at this diagram. It tells us that we have three different lines, CF, VE, AD, all making point A. And they want us to find all of those missing angles, 4 different angles. So let's go ahead and get to work. Looking at this, I see no 90 degrees. I see 180 here. But if I try to do that, I'm going to have nothing to put here. So that line won't work. And if I go the other way, I don't have anything here as well. So forget that line. Let's take a look at this other 180 line here. But on both sides, I get the same thing. Nothing here, nothing here. So that won't work. And if that 180 is not going to work because I have missing numbers, 360 is definitely not going to work because I have these missing numbers. So no 90, no 180, no 360. The only thing I have left is to find some opposite angles. So I see or said this angle is opposite of this angle. And like I said before, if you have one set of opposite angles, everything else has to be opposites too. So that means that this angle is opposite these two angles put together. Those two are opposites. But I'm going to use the one in green right now to find out what x is. So we're going to write our equation out. 8x plus 27 is equal to its opposite angle of 32. Start solving for our x. So we left with 8x on this side and 5 on this side. Divide both sides by 8, and we get x is equal to, now if you want to do 5 divided by 8, that's completely up to you, get a big long decimal, or you can just leave it as the fraction 5/8. So now we can go ahead and start figuring out what all of these different angles are equal to. So one of the angles they want me to find is the first one, BAC. And yeah, they have this equation right here. And if you want to plug in 5/8, you would see that you would get 8 times 5/8, which is 48, or just 5. And then 5 plus 27 is going to give you 32 degrees. And I knew that already because this side was equal to 32 degrees. So now we can start figuring out the rest of it. I'm going to go ahead and move on. We're going to look at angle DAE. Angle DAE is here. They give us an equation. It says 68x. We just found that x was equal to 5/8. So we're multiplying 68 times 5/8. And 68 times 5 gives us 340. And then obviously 1 times 8 gives us 8. And then when we divide, we get 42 and 1/2, or 42.5. So this angle is equal to 42 and 1/2 degrees. All right, so we most of the way there now. Let's see what's the next one they want us to find. They want us to find angle BAF. So they want us looking for this angle over here. Now, in looking at that angle, what I notice is that we do have a straight angle right here. So if I take that angle that I'm looking for plus this 32, that should give me that missing angle. So if I want to, I can go ahead and put, oh, you know what? I'm going to put a y for this right here. I'm looking for that. So that's going to be y is equal to, I'm sorry, not y is equal to, but y plus, taking that angle BAF plus angle FAE, and that makes a straight line for us. So y plus 32 minus 32 equal to 180 minus 32. Y is going to be equal to 148 degrees. So this piece, angle BAF, at y is equal to 148 degrees. So now to find the last one, which is angle CAD. CAD, like we said, we have this one is opposite this 148. So if I want to put another variable and use algebra, I can. I'll put a z right here. Z plus this 42.5, because we're looking at these two opposite angles being put together. So z plus 42.5 is going to be equal to its opposite angle here, which is 148. So we do z plus 42.5 minus 42.5 is equal to 148 minus 42.5. So that z is going to be equal to 105.5. So there is our last missing angle. And if you take, again, all of these angles, 48, 32, 105.5, 42.5, and 32, those go all the way around in a circle, and you should have 360. Now, this lesson 10 is our next lesson that we actually haven't done yet, but I'm going to go ahead and take the time to do a couple of problems in case people want to study for their test, or if you are sick and not in school right now. So here it says, sketch a picture that represents the angle relationship described, then determine all unknown angle measures. It tells us two supplementary angles have measures that are in a ratio of 3 to 2. What are the measures of those angles? All right, so first things first, I'm going to go ahead and sketch this picture as supplementary angles. That means that it's going to be two angles that form a straight angle. So here are two supplementary angles. They tell us that they're in a ratio of 3 to 2. So some ratios, that's some stuff that we talked about way back in 6th grade. But one thing that we talked about when we did ratios, I'm going to go ahead and name these angles real quick before I continue. I'll call this one angle A, and I'll call this one angle B. And what we talked about, one of the things that we used when we did ratios in 6th grade was we used a lot of tape diagrams. So if I want to use a tape diagram to represent A, it also says that they are in a ratio of 3 to 2. So because my A is my bigger one, I'm going to let that one be the 3. To represent this one is going to be 1, 2, 3 boxes. To represent B, it's going to be 2 boxes. Now what's going to go inside those boxes? Well, I don't know. And because I don't know what it is, I'll go ahead and put a variable. So this shows you using these tape diagrams that A is going to be equal to 3x, while B is equal to 2x. So A is 3x's, B is 2x's. Now I can see what my equation is going to be. It's going to be 3x plus 2x is equal to 180. Combine my like terms on the left-hand side and leave me with 5x. Divide both sides by 5. 180 divided by 5 is going to give me x is equal to 36. But that's not the answer. They don't want the answer. The question doesn't even say find x, but we know that we have to find x to get our answers. They want us to find out what is the measure of these two angles. So it's going to be, this one up here is going to be 3x. So we found x was 36. When we multiply 36 times 3, we find out that this angle is equal to 108. And here we're doing 2 times 36. And 2 times 36 is going to give us 72. Add those two numbers up, and it's equal to 180. And here we have one more diagram from lesson 10, where this one's different than anything else we've done before, because right off the bat, they give us two variables, an x and a y. So what I like to do with these types of problems is go through and try to fill in as much as information as I could. And obviously I can see I've got some things that I can add right here. Those two angles are equal to 90. So inside of those angles, I'm going to put this one's equal to 90 and this one is equal to 90. That also lets me know a little bit of information that if these two are equal, that means that they're opposites, which also means that this one is the same thing as these three put together. So that x, y, and 52 are all equal to 65. I just got to figure out a way to do this because I can't put x's and y's together in the same equation. I'm going to have to find one of them first and then figure out what the y is. So going through my steps, yes, I do have two 90-degree angles, but they're not made up of two different angles, so I can't put anything equal to 90 there. Looking at 180, I only see one straight line here, and that straight line is angle CFB right here. So if I look at that particular line, it kind of separates the x from the y. So I'm noticing that if I take x, 52, and 90 and put them together, it gives me that straight angle. So that's going to be how I'm going to find x. So I'll do x plus 52 plus 90 gives me that straight angle of 180. Combine my like terms will be 142. Start my algebra. This is a one-step algebra. So then x is going to be equal to 38. So I'm going to go into my diagram and put right here, x is equal to 38. So now, because I saw about that, those vertical angles, I can go ahead and figure out what y is now by taking these three angles right here. 52, now I know that x is equal to 38, and the y, and put it equal to its opposite angle up here, 65. So that's going to be 52 plus 38 plus y is equal to 65. I always like to put my variables first. So then I'm going to add 52 plus 38, and that's going to give me a 90. And now that I'm looking at this particular problem, I'm seeing that these are not opposite angles. So, because we only have one intersecting line, so I made a mistake right here, but that's not going to change what we're going to do. I'm just not going to do it that way. So our number 38 is still correct, but I cannot use the vertical angles to find out what y is. I'm going to have to figure out a different way. They would be vertical if this line came out here, but it didn't do that. Got a little confusing there. All right, so let's figure out a different way to find y. Oh, let's see. Any other 180s? Yeah, I could do 180 right here. Y plus 90 plus 65 is going to give me that one single straight line that I have here. So that makes it easy for me. Or if you want to do it a 360, you could add up every single one of those numbers since we know what x is equal to and make it be equal to 360. But I'm going to go ahead and go with this route. Y plus 90 plus 65 gives me a straight angle. Combine these two terms, that's going to give me 155. And then we subtract 155 from both sides. And that's going to give me 25. So this angle is 25 degrees. And now we have every single angle with a measure in it. Oh, I thought that was our last problem, but do have another one. All right, so number 6 from lesson 10. We've got quite a few x's, quite a few y's going on here. Also have some 90-degree angles, so let's slap in some measures right there. See if we can notice some things. And I do have opposite angles this time, for sure. These two are opposites, so that is 42 degrees. I know they're opposites now this time because every single one of these lines is a straight line. This one's a straight line. This one's a straight line. Right here and right here. So we got at least two. So I know I've got some vertical angles. And if those two are vertical, that means that these two are vertical. And then that also means that these two x's can go with these three y's. So let me go ahead and figure it out. I'm going to do it separately. I'm not even going to use vertical angles. I'm going to use straight angles. So to find x first, I'm going to go ahead and add 90 plus x plus 42. That's going to give me that straight angle. It's going to be 2x plus 132 is equal to 180. Subtract 132 from both sides. (180 minus 132 gives me 48, and divide by 2. It's going to leave me with x is equal to 24. So I can go in and put this is 24, this is 24. Now for the y's, I'm going to go ahead and do the opposite, but that's still with that straight angle. I'm going to do 42 plus y plus y plus y plus that 90 at the bottom. That makes that straight angle 180. Combine my like terms. And then subtract 132 from both sides. I just did 180 minus 132 and got 48. But this time it's being divided by 3. So 48 divided by 3 is y is equal to 16. So each of these y's is equal to 16. And if you do 16 plus 16 plus 16, that's equal to 48. 24 plus 24 is 48. So these x's and these y's were actually, like I said, vertical angles. And then here's a little extra problem that I found that is something different, and it shows why the algebra is so important. Working it out in steps like I've been doing rather than just doing a bunch of math all over the paper and then just circling an answer. So right here we can see that we have a 90-degree angle. These are complementary angles. So we're going to go ahead and add these two together. X minus 54 plus x minus 10. And that's going to be equal to 90. The first thing we're going to do is change these minus signs to pluses, changing the sign of the numbers behind them. Then we're going to combine like terms. So 2x plus a negative 64. And right here is where people start getting confused, because you have to do the algebra and you're like, whoa, what I got to do right here? I gotta do what? Well, to get rid of a plus negative 64, it's the same thing. And this is why the algebra helps you see it better. We have to subtract a negative 64. And if we're subtracting a negative 64 on one side, we have to do it on the other side as well. But now here, we got to go back and get rid of minus signs. So this becomes a plus. That negative 64 becomes a positive 64. And the same thing over here. If you don't do that step, if you don't do this process of algebra, you're going to sit there and go, oh, well, it's 90 minus 64. And it's not at all. It is 90 actually plus 64. So a negative 64 and a positive 64, those are still opposites. That goes away. We're left with 2x. Here we have 90 plus 64, which gives us 154. Divide both sides by 2, and we're left with x is equal to 77. And then you can go in and figure out what these missing numbers are. 77 minus 10, this one is 67 degrees. 77 minus 54, this one is 23 degrees. Add those two together and you get 90.